Math Book Club, where ordinary parents encourage one another to develop an extraordinary appreciation of math. We love what we know and struggle over the unfamiliar. Through weekly conversations and exploration among friends, we can begin to enjoy ideas that seem difficult. Join our book club as we discover how math helps us to know God and to make him known. I'm Lee Bortons, and it's Monday, February 20th, 2023. Welcome to the Math Book Club, where Kirsty Gilpin and I discuss a math concept each week from our soon-to-be-released math curriculum for families with students in classical conversations communities. Tonight, Kirsty is traveling, and she may or may not be able to join us, but meanwhile, our co-author of the Math Map, as well as the Vice President of Classical Conversations Multimedia, Sherry Swigart, will be co-hosting. Sherry, thanks for joining me.
Of course. I'm glad to join you tonight.
Should be fun. Okay, so I love how the scripture says multiplication when it means multiplication, and 100-fold or 200-fold. It uses the word fold when it means exponentiation. In fact, we have a related activity upcoming in one of our lessons in the Math Map. Sherry, why do you like mathematics?
I like mathematics because I like that you can learn to like it. Because I didn't always like mathematics. In fact, my senior year of high school, I didn't even take math because I so disliked it. But I love science. So I decided to go into engineering and knew I needed to learn some math skills. So it was a tutor that summer that unlocked the beauty of math for me, because she went back and taught me the things that I hadn't been taught in school, the grammar of math, the understanding, the governing principles, and I realized I could learn it and I could like it, and I grew to love it. And that's where my passion was born, to not have other people have math hidden, because we can learn it. And so several years ago, when I got to see you on your first tour for the Math Map, I thought, this is it. This is what we're looking for, to give that arrangement, that math map that gives us our stable canon to introduce people to mathematics. And that's why I'm just delighted about math, that it's God's language he's given to us, and it doesn't need to be hidden for us.
Yeah, that's great. Let's talk about that a minute, because a lot of people don't know I was on my way to being a history major in college when I had some similar experience. An aviator in our community helped me to allowed me to work on an airplane he was building. And that changed everything for me. It wasn't math that made me go into engineering either. It was wanting to just build things and know systems and be part of things that are bigger than myself. And I would say that's probably true for a lot of students. And yet we don't necessarily know to direct them towards engineering, do we?
No, it was my love of physics, actually, that drew me to the engineering. It was the applied mathematics and the science of it, chemistry, biology. I loved it all.
Yeah.
And
yeah. So maybe some of the parents listening can take that to heart. And if you see your children are just good at just putting things together, maybe direct them towards engineering. Meanwhile, the rest of us who are more like I was, before I went on to college, didn't really care all that much about mathematics. We're hoping that we can equip parents to learn to love it themselves, and then hopefully carry that over to their own children. So this book club's a little different, because the book is actually a math text that we're going to study over the course of a year. To access the Math Map, you need to be a member of Classical Conversations, a CC connected community. Please feel free to participate in the discussions, even if you're not in CC, as we will share things on the screens that we need to discuss math. So here we are. Let's just jump right into what Kirsty's prepared for us. So I want to talk this week about the exordium, and I think it's quite interesting, the one by Albert A. Bartlett. And maybe by the end of this hour, or 45 minutes, we could talk about it again, that the greatest shortcoming of the human race is our inability to understand the exponential function. I don't know if that means much to many people. What's it mean to you, Sherry, and anybody else who's listening?
well, at first it seems a little hyperbolic, right? It's the greatest shortcoming. And I actually, Lee, this is something I wanted to ask you about, to consider, because we Albert Bartlett, he was a physicist and he used it to show the impact of population on resources. He used it in a negative way.
Mhm.
But also, I just wanted you to speak to the fact that we take these quotations and these reflections, and the authors may not, you look at the context of the author using it, and our goal is to redeem it and find the truth in it.
Mhm.
And as I look at this and I look at the idea of an exponential function, that was God's plan from the very beginning when he said to be fruitful and multiply.
Yeah.
And the promise he gave to Abraham when he said, count the number of stars in the sky. And Abraham and Sarah hadn't had any kids yet. For him to believe, he had to believe in exponentiation.
Mhm. Yeah, that many could come that quickly, just like our pretty bunnies on here, right? So hopefully, I don't know if we said this enough yet in the previous weeks, but hopefully the artwork will act as a peg. And I would say this is probably our first difficult unit that we have in the math map. And so we have a very pleasant picture on the front of it in the hopes that, whether the children or the parents succeed in this lesson or not, that they'll always remember it's about the bunnies, because one day something will click, because exponents are everywhere. And hopefully they'll go, oh, that's what that bunny book was about. That's kind of my hope in having the art there. And that's true for any of it. So what are some things? So you talk about negative in the population growth is how he used it, but what are some of the ways that the exponential function is just in front of us, whether we see it or not, besides bunnies multiplying rapidly? Does anybody want to contribute?
Donna has a thought. Go ahead, Donna.
So I just think of, as homeschool moms, sometimes we just think we have no impact on the world. Like we're just here in our little bubble. But even if our little bubble is just one or two people, and then those one or two people go out and have impact on one or two other people, and then those have impact, it goes exponentially. It's the squares, we're going up, by two each time. And so 4 becomes 16, and it grows so rapidly. But we fail to see that. We fail to see it's like my one impact means nothing, but it does mean something.
Yeah. Yeah, we don't get to always see how, do we? So I think it's interesting that, when the scriptures do talk about the return being 100-fold. And I know that every Sunday when we give our tithes at church and the young men walk around collecting the tithe from us, my prayer every time is, Lord, do not multiply that times 100. Please do 100-fold return on what we've given, because we know that it's possible for you to do so. So some of the places that we see that and we know that it's possible is the numbers of blades of grass or the trees or the waves, that everything in nature is so much, it's all uncountable, like in which Sherry referred to Abraham and the stars. Exponentiation helps us to reach uncountable numbers really quickly. Uncountable in the sense of access to us. I'm sure Kirsty would say there's infinities that are countable to a mathematician. But just the variety of things that are out there. So, and it's not just growth, it's not just the quantity, it's also the growth rate and the decay rate. For those who don't know, the growth rate of almost everything, cell structures, pine cones, the way a nautilus shell grows, they all are related to exponents, as well as the way half-lives and things decay and die. So it's an important number in creation. And I always think it's interesting, so it's an important concept, that something is related to dimensions, as exponents are, which we'll talk about later. Exponents and just the big numbers they deal with, as well as the very small numbers they deal with. It's just one more place where Proverbs 2:25 comes out, and like the glory of kings is to search out matters. And we're just to try to see these numbers and find ways that they glorify God. So in a lot of ways, even though we've had a lot of conversation, we'll continue to in the first 6 lessons of ways that math can glorify God. I think 7 in exponentiation is the first time where there's like a largeness and a smallness that we get to meet the Lord in. So I'm excited about exponents. Okay, so we've said before that there's two things we've identified as making math unfamiliar, and tonight's one of those. It's really clear why math can be not so pleasant for so many people. It's a foreign language, and exponentiation has really unusual notation, very complicated notation. And if you have any kind of series of notation, it's even more difficult to read. So we're going to be practicing some of that after we get through some of these introductory remarks. So Kirsty would for sure want you to know that, look, exponentiation is week 7, which you see is still in the first dimension. And she put out these other lessons to show us that 11, 18, 25, and 26 in particular have more practice with exponents. And so we need to learn them in week 7 so that we can carry the math through. So a lot of people have asked us, like, what's our review process? And because of the math map and the ordering and going from 0 dimension through to n dimension, there's this natural review that occurs. You can't move to the next lesson if you don't bring with you the things you already worked on. And so here they are again in the lesson. So you get to meet them over and over again. Okay, so next slide, Julie. And there's 7. I don't think we need to stay on that one. Why don't you go to the next one? Okay, this is where we're going to actually do some math this week. Most of you are familiar with the idea of an inverse operation. So addition, what would the inverse be of addition?
Subtraction.
Right, and the multiplication, it's
Division.
right. The thing about exponentiation is there's 2 inverse operations, not just one. And so I want to get familiar with this, these symbols and notation, as well as some of the calculations that go with it. And then we'll end up talking about some of the philosophy behind exponentiation. So I'm actually going to ask you all to pull out a piece of paper and pencil, and we're going to do some math, which is not always easy to do through Zoom. So bear with me, and I'll wait on you too. And if you could do me a favor and basically get just a piece of paper and make 3 columns with the headers being these 3 formulas. B, and I'll read them to you. B equals the square root of P. I'm sorry, not the square root. B equals the nth root of P. P equals base to the nth power. And n equals the logarithm of the base to the power.
Yeah, one wouldn't have to know how to write that, Lee.
What's
How do you write that?
Oh, those are
You're
the
right.
top columns. They're written in there already. The B.
Okay, that's what I thought. Okay,
Yeah,
so
those
B
top.
N. Okay,
Yeah.
got it.
You might need to point it out on your screen since I can't.
Okay, so here, that's
Yes,
the
right,
first.
that first column, second
This
column.
is the second, and this is the
And the
third.
third.
Thank you. I'm sure
Mhm.
all of you understood what she was talking about. The able producer did not.
I'm not sure I understood, but Kirsty has really helped me in these years of doing the math and giving me kind of tips and tricks to hang things together and seeing how all of it's integrated. So this is one of her favorite lessons. So what I'd like you to do is let's start with the middle, because that's the one that's the most familiar. And go ahead under that heading of P equals B to the n, the center one. Write the number 9 equals 3, and then the n is called the index. Write a 2 there. In other words, 3 squared equals 9, but we're going to write it backwards. We're going to say 9 equals 3 squared. Then what I would like you to do is use one-to-one correspondence, which is a difficult skill for children, and write that 9, that 3, and the 2 in the first column where they belong and in the third column where they belong. Okay, in the first column, and I'm going to just go over this in detail, and then I'm going to call on all you guys after this first problem set. I wrote 3 equals, that's radical symbol with a 2 outside of it and a 9 inside of it. And you would read that as the square root of 9 equals 3. Now, here's my first question. Do we normally write the 2 when we have a square root? You're thinking no. We are really consistent through challenge A to always write the 2. Because that's one of the things that mystifies students is the hidden numbers. Like if you have x equals 7, really you're saying 1x equals 7. Or if you have x to the first equals 7, right? That 1 gets dropped. So with the younger grades, because we're focusing on notation, we write them all out. So then so 9 equals 3 squared in your middle column. And then what I wrote is 2 equals log 3 to the 9th. And the 3 is called a subscript. So if you look at the chart in front of us, the B in the right column is a subscript. The N in the center column is called a superscript. And the N in the first column is also called a superscript. And superscript and subscript just tell you where they live. It's just visually where the graphic is. All 3 of them you could treat as they're called indices, right? So that would be a generic word for them. But in order to not confuse things, I'll say subscript and superscript for this evening. Everybody following? You want to nod? Not? Does anybody have a question about that notation?
So just to clarify, just so I'm sure I heard what you said, Lee, that the symbols B, N, and P have particular names: base, power, and index. But when we're looking at where they're located in the equation, you're describing it as a superscript or a subscript to let us know where it lives.
Yeah, and so this is an important concept that will be carried over throughout all the lessons because mathematicians like to think in sets and sequences. And so they'll use subscripts to say like element 1, element 2, element 3, element 4, in the sense of they might say A1, comma, A2, comma, A3. So that's part of what makes math difficult is the notation isn't straight across like in a book. It can be up and down. And even if you're reading a chart, you have to read the whole way up and down as well as the notation moves on you. So give your little guys time to really see this and practice writing it. Okay, so most of us are familiar, I would guess, with the left column where we would say the square root of 9 is 3. The one that throws most of us is these logs. So for tonight only, over time, you'll get good at them. But for tonight only, it's a rule to follow. It's grammar. And an analogy I'll make is that you could flash cards for division, but normally what we do is we do multiplication so much that the division is just the inverse of it. We don't focus as much on memorizing division. We focus more on memorizing multiplication. Well, what happens is we tend to focus a whole lot on this middle column. And if you do that enough, and then you start writing it in the other 2 forms, you'll start thinking backwards. But that's not easy. You've got to practice these kind of equations a lot of times. So that's just kind of my tips for your kids. And we'll have flashcards available that will help you to practice this, as well as if you pay attention to N to K, the game that we play, the students verbalize the first and the second column a whole lot in that game, not the third column though. Right? So maybe that's something we can start doing in the, as we tutor, if somebody wanted to start adding the logarithmic form to knocking out numbers, that'd be great. Okay, so let's do this one more time. I'm going to give you different numbers for the middle. For P, write 16. And for B, write 4. And for N, write 2. In other words, 4 squared equals 16. Or the second power of 4 is 16. Kirsty wrote some words down below for us to practice saying them. We do have, there's 2 errors down below here. I guess this is one of our older slides. It's 4 to the 9th is 512. I don't know if you can change that, Julie, while we're looking at it down. If you can't, don't worry about it. It's 512. And that should say anything to the 0 power is 1, not 2. So we have a couple typos.
Yeah, I
Let me
can't
give
fix
you,
it, sorry.
that's okay. Does everyone see where I'm talking about at the bottom? Right. Yeah, that should be 512. And that 2, the 2 below it should be 0. Okay. All right, so if you're reading that, I just wanted you to know that we know there's a problem. Okay, so now that you wrote the 16, the 4, and the 2, go ahead and put them in your first column and your third column. I'm guessing some of you already did that. So who wants to read what they wrote in the first column? I'm calling you Donna.
Just looking for my mute button. 4 equals the square root of 16. So I have the 2 as the subscript outside of the, what's it called?
The radicand. The radicand.
Radicand.
Yeah, and you see that's really good that you did that, because if we're trying to communicate to someone, we say that thing. They don't know what thing we're looking at.
Check mark, yeah.
Yeah. Okay, so the third column, would you write, Donna?
2 equals log subscript for 16.
Good. Perfect reading of that. All right, so the first thing to do is just practice this pattern and start. I always start with the middle one because that's what I'm most familiar with. I know a lot of my squares and cubes. So let's explain what that is in a second. And then I practice my first column, and then I practice my third column. And that's kind of the order I have to go in for it to make sense to me. So let's do a different number, and then we're going to talk more deeply. Okay, so in the middle column, let's say 8 equals 2 to the third. So the index is 3. 8 equals a 2 and a 3. So let's back up and be even more basic. Before, when we had 4 squared or 3 squared, that meant the same as saying 3 times 3 or 4 times 4. There's 2 of them. Now, when I say 2 cubed, I mean 2 times 2 times 2. In other words, there's 3 or cubed numbers of 2. So 2 cubed is 8, right? Because 2 times 2 is 4. And 4 times 2 is 8. Everybody following? Who knew you could do math over Zoom? If Kirsty was here, she's got a really nice whiteboard she can use. Okay, so fill in the left and fill in the right. Okay, so let's look at the 3 we did on the first column. The base equals the index c to the root of the power. When it's we had the 2 by the 9 and the 2 by the 16, and now we have a 3 outside of the 8. Everyone following? Okay, that tells us something. What is the square root of 9? Well, that 2 there tells me there's 2 answers. What are the 2 answers to the square root of 9? Amy Jones wants to say it, I can tell.
3.
One of them's 3. What's the other one?
3 times 3.
That's one answer is 3 because it's a root. What else is there?
3 2s.
3, 2. Yeah. No, wait.
No, square root of 9? That's okay,
Square root
girls.
of
That's
9.
for you.
Oh, good. 3
Negative
times.
3 times negative 3.
Negative 3.
Ah, good. That's
Positive,
good.
negative.
What makes it a root is what makes it the square root is it's itself 2 times. So 3 times 3 is 9, and negative 3 times negative 3 is 9.
That's good.
But is negative 3 times positive 3 9? No, that's not a root. There's just 2. And so we might write in front of your 3 a plus and minus sign. You guys familiar with that? Plus and minus 3 equals the square root of 9. Okay, so let's practice one more time. Thank you, Amy. With the next one, what's the square? So if it's a square root of 16, that means there's 2 answers. So one of them is what? Who wants to be brave? Go ahead, Julie.
Positive and negative 4.
Positive and negative 4. Who said that?
Donna.
Oh, Donna, I couldn't tell. So those are your 2 answers, positive and negative 4.
Can I ask
Okay.
a question? Okay. So, but if we're starting with the center column and we're stipulating that it's 4 squared is 16, is negative 4 still valid?
Yes, it is. We'll go back to that in a minute.
Okay.
So in other words, what you could have had is, but you have to write it right. Let's answer your question now. Where you said 9 equals 3 squared the first time,
Mhm.
put a negative in front of it. If you have -3 squared, it's wrong. It will not be 9. You have to put parentheses around the -3. Because negative times a negative gives me a positive. And a 3 times 3 gives me 9.
Mhm.
All right. So on the next one, 16, if you put a negative in front of the 4, same thing, parentheses around it. So -4 squared is 16. So we put a plus and minus in front of the 4 in our first column. Because +4 is the square root of 16 and -4 is the square root of 16.
Beth, do you have a question? Go ahead.
I don't know who it was that was just asking that previous question, but I think I sympathize with that. Because I remember going back and teaching like, oh, my brain's gonna fail my words now. But when I was teaching inverses, if the original function had like a restricted domain, then the inverse function would also have a restricted domain. So because the middle column starts off with +9 equals +3 squared, are we then saying that the 3 equals the square root of 9? Is that dependent upon the middle column? I think may have been what she was asking. And so I think that's a good question. I used to tell my students, and obviously this is different place, different time, but like if you have to introduce the square root to solve, then you must always have the 2 solutions. But otherwise you use the sign that's there. But
Yeah,
like I said,
that's really
different
great,
time.
Beth. That
Right.
you brought up domains, because here's the thing, when we're working on something like this with our students who are studying digits and naturals, we would never give them anything negative because it's not their domain. But as soon as we get to integers, we can start talking and introducing these ideas to them. So this is a place where the word domain really matters to mathematicians. And so if what you said is true, visually, if there's a positive and on both sides, that's the only answer you're looking for. And it's called the principal root. Right. But if you say, no, I want the domain, I want your answer to be in the whole domain of integers, then you're going to think, well, what in the world is she asking about? Which comes to the next one we're going to do, because it even adds another dimension to this. Okay, so we had 8 equals 2 cubed, and they were all positive. And we came up with the left column, the first column saying 2 equals the cubed root of 8. So if you wrote that 3 in your indice, what should that tell you? How many answers are there? 3. That's what that means. There's 3 answers. Okay. So 2 equals the cubed root of 8. What are the 3 possible answers? This is where it gets tricky. Its principal root is just 2. 2 times 2 times 2. That's the natural answer. But what else could there be? Carrie?
-2 times -2 times 2.
But that's not exactly the same number. But good
Oh.
try. They have to be exactly the same.
And they have to be integers.
Okay, so here's where that is a great question. And it'd be wonderful if students always ask that. So no, if there's 3 answers, they can be from any of the domains. So the other 2 answers that you can't see easily are complex numbers that have imaginary parts.
Okay, got it. Yep.
So in challenge A, the students will get introduced to imaginary forms of numbers.
Okay.
They won't do a lot of hard math with them, obviously, at that level, but they'll start reading them. So in other words, we live in this amazing world with concrete ideas, but every now and then there's something that it's imaginary. It could possibly exist. It's not concrete. And yet the imaginary numbers, and why they're so important, is they are what help us go from the concrete world to the abstract world back to the concrete world. So for example, If you were dealing with, let's just say satellites in outer space, and you're trying to figure out how something spinning, which is what a satellite does, rotates around an Earth that's spinning while it all spins around the solar system, and you're getting more and more dimensions, and you're trying to figure out how to rotate things and get a straight line where a rocket can go from one of those spinning things to another spinning thing. The math calculations require imaginary numbers. But when you land and when you take off, they better be real numbers. So this is a place where you get to see the unseen. And so let's do one more, and then we'll have to finish this conversation. So in the middle, with, oh no, wait, yeah, in the middle, if you write 512 equals 2 to the 9th power, which Kirsty would tell us to say the 9th power of 2 is 512. Can everybody at least write the first column and the third column, even if you don't understand it? And we're going to stick to the realm of natural numbers here. So is everybody able to write the main problem and the 2 inverses? Who wants to practice reading what they wrote across the page?
I will be brave.
Thank you.
Okay. 2 equals the 9th root of 512. And then we have 512. Oh, hold on. 512 is the 9th power of 2. Is that how we say that?
Sure.
Okay.
Or you could say 2 to the 9th power.
Okay.
Either way.
And then, oh, I have something wrong. Hold on. So the index is first on the log.
Yeah.
So 9 is, I want to say log base 2 of 512. I'm not sure if that's right.
No, he's right. Okay, perfect. Very good job. Okay, so tonight we talked a little bit about the idea of that these are inverses, whether you understand it or not. That it's a plug and chug grammatical problem for young folks or or people that are new to it. Just move those numbers around and get familiar with them. And then there really is a practical use as well as abstract that points us closer and closer to seeing the universe the way it is and knowing more about the Lord. So Julie, because of time, I'm thinking we're almost out. There's my ad. Thanks for posting it. Let me put it back. I want to see my ad. There we go. You ready? I'd like to thank our sponsor, Classical Conversations, ccconnected.com, where the math booklets discussed by the club can be downloaded by Classical Conversations members. And you can look ahead to the book club schedule on leebortons.com under the Math Map Book Club tile. Next week, work through lesson 8, which is equations. Go to CC Connected to download the Math Map Naturals, which is in the beta form, which means it's not perfect. You don't have the answer key yet. You don't have the flashcards yet. Remember, it's meant for first graders, so anybody should be able to work through that curriculum. And if you have any questions, come on a Monday and put it into the chat. Okay, so before we go to, let's see, yes, this slide. Did Kirsty make it on? Is she listening? I'm trying to give her time to get to the hotel. No?
I do not see her unless she's
Okay.
on her phone. Nope.
She just really likes talking about this, so I was gonna let her if she was here. So not that I dislike it, she's just good at it. Okay, so this is one of the places in math where like the trinity stands out, because a lot of things in math have to do with fours. If you think of like geometry, you know, 4 quadrants, or if you think of 3-dimensional space, there's 8 octants. If you think about the inverses or even opposite numbers, there's a lot of 2s, but this is a place where 3 really stands out. I wanted to know if any of you can think of other places where the idea of 3 stands out in math.
I just thought of like the third dimension, because there are, so anytime you have a 3D shape, you're working in 3 with 3.
Yeah,
Trig- Trigonometry.
trigonometry. Yeah, just that word trig goes to try, because there's 3 relationships. So they are sine, cosine, and tangent, and everything comes off those 3. And what is it, the shape that trigonometry is describing?
A right triangle.
Triangle,
Yeah,
right? Triangle.
triangles, right? Yeah, so these are just, you know, rudimentary math concepts where we can meet this idea of Trinitarianism or 3ness and see how numbers need one another. There needs to be 3 of them, or the laws fall apart. So can anybody tell me a shape that occurs in nature that's the shape of a triangle?
An evergreen tree sometimes.
That's good.
Shadows.
Shadows.
Shadows make a triangle with whatever they're shadowing.
Okay, I like that one.
Constellations?
Like you think about when you connect 3 stars? Is that what you mean?
Maybe. That just came to mind.
Yeah.
Mhm.
So the reason I bring it up, how much time do we have, Julie?
Mountains. We have
Yeah.
7 minutes.
Okay, good, we have time.
Somebody said mountains.
Okay. So as you pursue your math education with your children, look around and look closely. There's not a lot of triangles in nature. There's things that are close to triangles. There are some, but like there's no mountain that's truly a triangle with 3 straight sides. In fact, it only has 2. Who knows what's down below? It's just it's something that is interesting. So, for instance, the strongest shape is a hexagonal shape, 6 sides. So there's lots of things in nature made with 6 sides, but there's not very many things with 3 sides. I actually can't tell you of any that are truly 3 sides that are straight. That. So that would be something to challenge your kids with. Are you thinking about that? Okay, then another question I wanted to ask you too was, or not a question, but something that has been important to me in studying the 3ness in math is that, you know, we couldn't have any of this, any of the math we do, if the Lord hadn't told us there's one God in 3 persons, the second of which is Jesus Christ. He right from the beginning in describing himself uses both ordinal and cardinal numbers that are on that are natural numbers on the number line. And so I always think that that's just interesting to find any kind of connection to 3s as you look at math. So challenge you to think about that with your kids. Okay, so with that, I'm pretty much done unless you guys have other questions now. Oh, parent-child relationship. Explain that, Donna.
I was just thinking something that occurs in 3s in nature, and it is the parent-child. It doesn't matter if you have 500 kids or 1, there's always 2 parents to 1 child.
Yes.
Even with twins, it's still 2 parents, 1 child.
Mhm.
So you get your 3 there. Yeah, I was talking more about the geometry shape of a triangle, but that's
Yeah.
great too. What are some other 3s?
What else? I'm pretty impressed. We did several math problems at 8:40 at night.
Well, then let's do this, because if you don't have any other comments, let's look at this page for one more minute, then the one that's in front of us now. Does anybody have a question about any of from 4 to B to 4 to 125 to 2 on the left and reading it across? Thanks for making it larger.
I did have a question when we were talking about using like the positive and the negative on the square roots. So when we were talking about the square root of 16, for example, being positive or negative 4. So when you're writing that as a log, would you have a subscript plus or minus 4 on the log side?
No. Sherry, if you want to explain that more, I'm trying to find my note on that.
Okay.
Or is she stumping us?
No. Well, I think plus or minus 4, because it's the base 4 and it's not negative. We don't have the negative bases in logarithms.
So that's part of the restriction of the logarithm. You cannot have a negative base. Okay.
Which is
That
good.
would be interesting to think about, though, when you think about
Yeah.
exponential growth positively, like, Okay.
Yeah, I mean, really, what is a logarithm besides a notation that says, I want to know what my index is? Like, I can see in my mind something growing exponentially, and I can see in my mind the roots of something because I can see squares, or I can see how a curve crosses a line that has roots. But logs, they're hard to imagine until you're really good at, I mean, they're good for scaling, right? I can see a logarithmic scale and understand that, but if you told me to understand the numbers, I don't. Does anybody have any ideas on that?
Donna wrote in the chat that Kirsty shared on Friday, the use of positive negative is dependent on the problem being asked or solved. She just
That's why it's not used in the logarithm, because it wouldn't be negative. It would never be negative. And then the use of it in other situations just depends on what it is you're trying to solve for, is what she explained to us on Friday.
I think it's from where you start, because I think that's the question we had earlier, Lee, because when we went from the middle to the left, that's what caused confusion. It's because the square root of 16, we don't know what the original number was, whether it was the negative or the positive, and we have to show both. But if we know it's 4 squared positive over there, that we started with that. So we know it's the positive 16. So I can see why you were saying the domain's limited when you went from the middle to the left column a little bit.
But heading to the right column is where angels fear to tread, apparently.
I know, right? I like the middle and the left, yes.
I know. I like the middle. I still need my form to figure out.
Well, and this is why Kirsty gets so excited about this unit, is because this was something that was unseen that she saw. The beauty of the trinity, of how these equations, one is the inverse of other. She hadn't seen it connected quite this way until she was writing this curriculum. And then she discovered that and gets delighted to show and share that with others. And it's just, we continually get to uncover these beautiful things that the Lord created from the beginning.
I'll give you a little trick I do for logs, but it took practice. So when I see the word log, I say to myself, like, let's do the first one. 2 equals log subscript 3 to the 9th, or to 9. What I say to myself is, the word log means to me, what do I have to do to a 3 to get to a 9?
Oh.
So what do I have to do to a 4 to get to a 16? What do I have to do to a 2 to get to an 8? So that's how I think of it now.
So read down that right column, Lee, how you would it be, what do I do to a 4 to get to a 16?
What I do to a 5 to get to a 25?
And
So-
that says the subscript, that gives you the subscript number.
Yeah, well, would give you the index n. So here,
Oh, yes,
a
sorry.
4, what do I do to a 4 to make it a 16? I square it. What do
Right.
I do to a 5 to get 25? I square it. I don't know why the n's there. What do I do to a 4 to get to 64? I cube it, because 4 times 4 is 16, times 4 is 64. What do I do to a 5 to get to 125? And even if it's on the left side of the equation, it's still the same. What do I do to a 2 to get to a 32? Well, I have to multiply 2 times 2 times 2 times 2 times 2.
Oh my goodness, I feel so smart.
Yeah, that was worth the
That is a
wait.
good trick. I love your tricks.
Doesn't mean I understand it quickly at all, but that's what helped me.
Mm,
Yeah, and there's
Would-
how reading it out loud and following along. Math is not a solitary skill. Your kids need to say things out loud, and so letting them read this would help.
Well, and too, I used, before we found Saxon, I used Singapore Math, which actually taught it that way. Like we were doing multiplication and division very young, but it taught it as the inverse. Like it was, if we did 2 times 2 is 4, we did 4 divided by 2 is 2. Like it was all part of the same sentence. And so I felt like that was really a great bridge when it actually got to division, because they didn't have to struggle with so I feel like this is what you do to not struggle with the big equations.
Yeah.
You learn the inverses, and it's like,
So the students who are doing N to K really well, and they're doing the left and the right column, I don't think it's going to be a big bridge if they would just say aloud the logarithms. They would catch on to the patterns really quickly.
I think if you introduce them all at the same time, once you've got all three, like you wouldn't have to struggle with the left or the right from the middle. We always, or at least I learned the middle, and then we were taught the left-hand side, and then we spent a half a day on the logs, and we're just told how to do that in our fancy calculators. We weren't told what it was or how to do it. We may have been told a little bit, but we quickly forgot that because we were shown, oh, this is just how you plug it into your calculator.
Right. But we do it right from the beginning in the math map. We show all three of
Yeah.
them. Okay,
Right.
well, I'm done. If you're done, I'm done.
I'm done. Apparently the slideshow is done too.
Thank you, Sherry, for co-hosting, and the rest of you for coming back. We'll see you next week while we put all the last 6 weeks together and do equations. Good
Oh,
night.
fun. See ya. Bye.
Thank you.